My name is Nabila binti Muhammad Nazri.
My name is Fatihah binti Muhammad Sazali. We'll be presenting about Chapter 7, Colloid and Surface Chemistry, under subtopic of Adsorption.
Hi, Assalamualaikum. Today we want to talk about adsorption under Chapter 7, Colloid and Surface Chemistry. Okay, now we want to define about adsorption, which is adsorption is a process in which a substance becomes attached to the surface of a solid or liquid. This process must be distinguished from adsorption, which the substance become distributed throughout the solid or liquid. Adsorption is limited to the surface only, while in adsorption, the molecules of the adsorbed substance are dispersed throughout the bulk. The substance on whose surface adsorption take place is called the adsorbent. The substance that get adsorbed is called the adsorbate. The quantity of a substance adsorbed per gram of the adsorbent can be expressed either in terms of the mass of the adsorbate or the number of moles of the adsorbate or the volume of adsorbate if it is a gaseous substance. In the formula, let X equal to mass of adsorbate, M equal to mass of adsorbent, X over M equal to mass of adsorbate per gram adsorbate. Okay. Nak tunjuk yang cakap tu.
There are several terms in this subtopic of adsorption. The first one is adsorbent. Adsorbent is the surface of the solid material. Next, adsorbate. Adsorbate is the gas or vapor or liquid contacting the adsorbent. The third one, adsorptive, the gas or vapor or liquid in the bulk phase. Next, adsorption, the process of the accumulation of material on the adsorbent surface. Next, desorption, the adsorbate in the condensed phase passes from the surface of the adsorbent to the fluid. Absorption, a process involving bulk penetration of gas or liquid into the structure of the solid or liquid, which is usually associated with an increase in the bulk volume. Sorption, a process involving both adsorption and absorption simultaneously. There are 4 factors affecting adsorption. The first one is nature of adsorbate and adsorbent. The second one, the surface area of adsorbent. The third one is activation of adsorbent. And the last one is experimental condition. For example, temperature and pressure.
There are 2 types of adsorption process, which is physisorption and chemisorption. For physisorption process, the attachment of the molecules to the surface is by weak molecular force, which is van der Waals force. There are no permanent bonding forms, and when the molecules are attached by itself to the surface, it is not chemically modified. It is readily reversed by lowering the pressure of the gas and the concentration of the solute. The length of the adsorption depends greatly on the specific nature of the solid and the molecules that being absorbed, and is a function of pressure and temperature. Molecules of vapor may be adsorbed to the depth of many monolayers, which is multiple layer. For chemical adsorption process, the strong covalent bonds make the molecules attached to the surface, and the incoming molecules is modified. It is occur when a chemical bonding form. The bonding may be too tight that original species may not be recovered, which is irreversible. It is limited to the formation of monomolecular adsorbed layer. For example, when oxygen is adsorbed on graphite, heating the surface in vacuum yields carbon monoxide. Okay, for this, multi-layer adsorption is on solid. The first layer may be physically or chemically. Subsequent layers will be physically absorbed only. This is the first layer, second layer and third layer. This is the physically or chemically adsorption. For adsorption, there is two types, which is physical adsorption and chemical adsorption. For physical adsorption, the heat of adsorption is less than about 10 kilocalories per mole, and for chemical adsorption, the heat of adsorption is greater than about 20 kilocalories per mole. Adsorption is appreciable only at temperatures below the boiling point of the adsorbate, and for chemical adsorption can occur at high temperatures. The incremental increase in the amount of adsorbed increases with each incremental increase in pressure of the adsorbate. The incremental increase in the amount adsorbed decrease with each incremental increase in the pressure of the adsorbate, which is occur in chemical adsorption.
For physical absorption, the amount of absorption on the surface is more function of the absorbate than the adsorbent. For chemical absorption, the amount of absorption is characteristic of both adsorbate and adsorbent. Physical absorption, no appreciable activation energy is involved in the adsorption process. But for chemical absorption, an activation energy may be involved in the adsorption process. Next, in physical absorption, multilayer adsorption occurs, while in chemical absorption leads to at most a monolayer.
This is two types of adsorption, which is monolayer and multilayer. Monolayer is all the absorbed molecules are in contact with the surface, which is we know as adsorbate. So here we look at these molecules. Just one layer will attach to the surface. For multi-layer, in multi-layer adsorption, the adsorption space accommodate more than one layer of molecules, and not all adsorbed molecules are in contact with the surface layer of the adsorbate. So, for the first layer, we see it's were contact attached to the surface, but not at the second layer or third layer. Adsorption isoterm. Isoterm is an equation which relates the amount of substance attached to the surface to its concentration in the gas phase at a fixed temperature. It has two models, which is Langmuir model and Bruno-Emack-Taylor. Which is Langmuir model, it is just one layer. It's attached to one surface, just one first layer. For Bruno-Emack-Taylor, which or known as BET model, which has many layer, multiple layer. For Langmuir isotherm, it is a semi-empirical isotherm derived from a proposed kinetic mechanism. Langmuir isotherm described as a single layer adsorption which the volume of gas molecule adsorbed at certain pressure. This isotherm was based on different assumptions, one of which is that dynamic equilibrium exists between adsorbed gaseous molecule and the free gaseous molecules. Molecule of the nitrogen and hydrogen can be absorbed by activated carbon. When the site of adsorbent completely filled, the monolayer formation is complete.
The amount of adsorbate at a given temperature is measured as a function of gas pressure P in equilibrium with the solid adsorbent at constant temperature and called adsorption isotherm. Langmuir theory suggests that the rate of desorption is proportional to the number of gas molecules attached to the surface, which in turn is proportional to the fraction to the surface covered, theta. Rate of desorption equals to K1 theta, where K1 is a rate constant. Rate of absorption is proportional to the concentration of the adsorbed molecules, which is proportional to the applied pressure.
Okay, the four assumption of Langmuir isotherm is okay, the first one is the solid surface of adsorbent is uniform. All the adsorption sites are equivalent. Every site has same energy. It is homogeneous surface. The second one is adsorbed molecule do not not interact. Adsorption is localized. It is immobile. Which is the adsorbent and which is adsorbate. Okay, for third one is all adsorption occurs through the same mechanism, and the last one is a maximum of the layer is one only. One adsorbate molecule per site can be absorbed. Adsorption cannot proceed above monolayer coverage. This is.
For Brunner, Emmett and Taylor, multi-layer absorption also occurs, especially in physical absorption. BET isotherm is used to explain the multi-layer absorption. The absorption process can be described in terms of the attachment of molecules directly on solid surface, the attachment of molecules to site already occupied by absorbed molecules, forming the second layer. PET isotherm describes the absorption as the ratio of the volume of gas that is absorbed, V, to the volume that would produce a single layer, Vs. Next, the build-up layers can continue until, as the gas pressure approaches the vapor pressure of the gas, the adsorption has reached the stage where the surface could be described as wet due to vapor condensation as the pressure increases. That's all from us. Thank you. Mana komen? That's all from us. Thank you.
Please subscribe.